Jai Hind. Today we are going to discuss a very good topic, pointers in C. It is a very useful topic for C programming because many kind of data structures will be used with the help of pointers. So, pointer is a topic which needs to be understood very carefully, and it is basically a facility given to the developer to deal with the actual physical addresses given to the variables. Many programming languages do not allow such kind of accessing of actual physical addresses of the variable, because it has a security concern. You may travel in the memory space and you can disturb the working of system, or you can enter in a restricted area of memory where the operating system, or you can disturb other variable values also. So, many programming languages do not give access to the actual physical location of a variable, whereas C is a programming language which gives us this facility, because many embedded programs and many system level programs are being developed in C programming language. So, it is definitely requiring to access the actual physical location of the variable. So, what we store? We store some kind of data into the memory. Every data has some identifier associated with it. Identifier is just the name given to that particular data, and a data type is also associated with the data, because this data type will decide how much memory will be requiring to that particular data. And the content of data may be of either they are containing some value or they are containing some address. If they are holding address, then this will lead to that it is a kind of pointer variable. If that means what I am saying, that if we are we are having a variable whose content is a address. So, what I can say, like the pointer is a special variable which holds address of other variable. So, if it is a value, then it is a normal variable, but if it is an address, that means it is a pointer variable. So, in many programs we may require to have access of memory locations for some variables. That means we need to hold the address, and these memory addresses are generally in the form of numbers, and they can be assigned to some variable, and that variable will also be stored somewhere into the memory. So, such variables that hold memory addresses are called pointers, and these pointers are itself a variable. So, they are also stored somewhere into the memory. So, like a pointer is a special variable that contains the address of another variable. That means they are not having the value directly, rather they are having the memory addresses of another variable. So, like we can declare a pointer like data type and asterisk symbol and the name of the variable. This asterisk symbol is called the dereferencing operator, or this is used to tell the compiler that we are going to use this variable as a pointer. So, like here in this example, I am having one integer x and given the value and assigned it a value 5. So, here the identifier is x, the value is 5, and for example, like we take it is stored at memory location 4576. So, it is the physical location of variable x. It is stored into the actual location 4576, and we declared a integer pointer p, and we given the P equal to address of X. So, I've used here the ampersand because ampersand is a address of operator or the reference operator which is assigning the address of a variable. So, this address is stored in P. So, what is happening? So, pointer name is here P and it will be having its value is the address of variable X. You understand that the address of or the memory location of variable X will be given to the will be stored as a value for the pointer. Like to better understand graphically, so we are having a location 4576, X is assigned, the value is stored into the memory and we are having a pointer P and P is having address of X. So, P is stored at location 1348 and it is having the 4576 as a content. The address of variable X is stored into the pointer P as a content. So, it will be consuming some memory area. So, pointers depends like they may have memory requirement for 8 bytes. In some compilers they have 8 byte requirement. So, they will be stored somewhere into the memory. Here the ampersand operator is called the reference operator or we can also call it a address of operator because it provides the address of X, it provides the address of a variable or address of the operand, and this asterisk is called the dereference operator or the value at address. So, one more example here like this picture I have taken from the book of E. Balaguruswamy, and like 1004 is the location of a character variable and integer variable requiring 2 bytes is stored at location 2008 and 2009 and float variable requiring 4 bytes is stored at location 7006 and corresponding 4 bytes. We are having a pointer CC, pointer II and pointer AA. So, pointers are storing their initial address 1004, 2008. So, this is stored in this and 2008 and 7006 is stored at AA, as well as they are having their own locations also. So, what pointers, where pointers can be utilized? The pointers are useful in when we are performing dynamic memory allocations because dynamic memory allocations will be done with the help of pointers only. The dynamic memory location is basically a concept where we are not allowing the memory in the beginning and we are helpless in growing or shrinking it. So, dynamic memory allocation allows us to increase the memory as per the requirement or to decrease the memory when there is no requirement to efficiently use it. We use pointers in case of linked list because linked list is always having a self referential pointer which is referring to the next node. We use pointers in data structure tree and graph data structure. We can have pointers as function parameters. We can have pointers for file input output and for IPC inter-process communication we can use the pointers also. Now, how these pointers are manipulated in C? So, we can access the address of a variable using this address of operator. This is our address of operator. So, we use this and this address will be a numeric value. So, we can display this address with the help of %u. %u is basically for unsigned integer value. So, this format specifier is used for unsigned integer value. So, %u we can use or we can use %p, that is also displaying the memory location in the hexadecimal form. It is displaying in the hexadecimal form. So, we can display in hexadecimal format, or we can display simply as an integer using %u. So, like here in this example, we are having an integer variable a given value 10, and we declared a pointer p. So, pointer will hold the address. So, we assigned address of a to the pointer. Now, how these variables, how these value or addresses can be accessed. So, if we want to have the address of variable a, address who is holding pointer. So, we can simply give the name of the pointer ptr, it will return the address. If we want to have the value, then we can use asterisk ptr. Asterisk means this was what? Value at address, or it is called dereferencing. What reference we have created, and to reach that value for dereferencing we use asterisk operator. So, if we will use asterisk ptr, then we will get the value. If we will use ptr, then we will get the address. We can get the address with the help of address of operator also. So, this address of ptr, it is giving the address of the pointer variable. So, it is different from the previous one. The previous one was 24 and it is 26. That means this kind of compiler is containing 2 bytes for integer, because pointer is allotted somewhere else after 2 bytes. That may be somewhere else, that may be a random number where this pointer is stored. Now, accessing a variable through pointer. If I want to access a variable, then we can use this dereferences. That means it will give the value, or like we can use asterisk address of x. So, what we are using, like value at address and what address of variable. So, value is address is asterisk, and address of a variable is something like this. So, this is basically a shortcut without using the pointer name. So, that we can also do. Now, as pointers are basically some numeric values referring to the addresses, physical addresses of the memory. So, in that case, we can use these pointers as a numeric value, or we can apply some operations, arithmetic operations onto pointers also. But every operation is not possible to apply on the pointer. So, pointer arithmetic allows only addition, subtraction, increment, decrement and comparison of these pointer variables. Like if we want to add an integer to a pointer, so what will happen? So, the address of the pointer, where the pointer is referring, number to be added into bytes of memory required by the data type. So, that will be happen. That is not happening like if pointer value is 1000 and we add +1, so it becomes 1001. No, like if we are having a integer variable like int I equal to 10 and we are having a pointer ptr of type integer and having address of I, then if I perform ptr +1, then what will happen? If like its address was 1000, then what will happen? 1000 is the initial address plus number to be added is 1 into bytes requirement is 4, because it is a integer type. So, the next address or the result will be 1004 rather than 1001. So, if we add a 1 to integer, then it will add 2 or 4 for every increment. If we add to a character type pointer, then it will add 1 for every increment. If we add to a float type pointer, then it will add 4 for every increment, and for long it will again add 4 for every increment. So, these operations can be performed. If we subtract, the similarly values will be subtracted from the address of the pointer. So, they can be assigned an address of ordinary variable, or it can be a null pointer. Pointer variable can be assigned the value of another pointer variable also, that becomes the double pointer. Integer quantity can be added or subtracted from a pointer variable, and their address will be incremented subsequently in what kind of data it is referring to. So, pointer arithmetic is meaningless unless it is being performed on an array. In case of a normal variable, if we are adding something, we are simply traveling to another memory space which may be occupied by some other variable. So, if we are performing arithmetic, then it should be on a pointer to some arrays, because there will be chance of getting another next element in that array, but in case of normal variable it is useless. So, here is an example like integer pointer ptr I equal to 5, and we have assigned the address of I to the ptr, like for example address of 1000 is given, and we performed increment ptr plus plus. So, in the previous what I have told you, that number to be added multiplied by size requirement. So, number is 1, plus plus means 1, increment 1, and the size requirement is 4. So, the next address will be 1004, ptr is having 1004. So, like we done plus plus asterisk ptr or this. So, it increments the value. If we are using pointer in the brackets, then it is referring to the value, and if we will apply the increment decrement, it will change the value rather than the address. So, here is an example. Here we have integer pointer, float pointer and double pointer. Everybody is will be stored in the same size of memory, but they will be referring to different data types. So, like if they have given corresponding addresses, float pointer is having float variable address, double pointer is having double variable address. So, for example, if it is assigned 1000, 2000 and 3000, and if we perform integer pointer plus 3, then what will happen? 3 into size requirement. So, 3 into 4. So, this address will be 1012, whereas float is again having 4 size requirement. So, 2 into 4. So, that will be 2008, and double is having different size requirement. So, 5 into 8. So, that will be 40. So, if we are adding something to the pointer, the next address will be calculated with the help of what kind of value it is referring to. We have in the C, there is a strong relationship between pointers and arrays. So, whenever an array is declared, the compiler allocates a base address and the corresponding memory allocations in a contiguous bytes. So, sufficient amount of memory is stored. So, the base address is the location of first element or the element at the index 0. Any operation that can be achieved by array subscripting can also be achieved with the help of pointers. As we have learned the pointer arithmetic, if we add, we will move to the next element after 4 bytes, like for in case of integer, after 4 bytes next integer will be there. So, we can reach to next element using pointer arithmetic also. So, the pointer version is in general faster than the subscripting method. So, like if I am having one integer AR of size 20 and I write AR I, so that is subscripting, or we can write AR plus I. So, that will be a different thing. that will be using pointer. So, like here we are having an x variable pointing to a 10 sized integer, and so its initial address is something. We have a pointer and we assigned the initial address or the address of first element. We can also write simply the x also. So, every variable is stored here. So, p and x now points to the same memory location. X is the name of array, and name of array always points to the base address. So, base address is assigned to p. So, they are pointing to the same memory location. So, we can write p plus I is same address xi. So, this is subscripting method and this is pointer method, which is faster than subscripting. If we write asterisk p plus I, then we will get the content what we get with the help of xi. So, x plus I is also identical to p plus I, because x is also the name of the array is itself a constant pointer. Constant pointer means it cannot now point to different address, whereas p is an independent pointer. So, it can have any address assigned to it. Xi can also be written as asterisk x plus I, because it will get the next address and asterisk will get the value. Address of xi is equivalent to the x plus I, pointer arithmetic. So, we will move to that particular location. If I write pi, so that is equivalent to the asterisk pi, and p is equal to x and p plus plus is legal, whereas x plus plus is illegal. X plus plus is illegal because the name of an array is not a pointer, or we can say name of array is a constant pointer. So, constant pointer के case, in this case we cannot add the value to a constant pointer, because it cannot change its address. Here is another example, like I am having one array 5 and we are having pointer ptr, which is assigned a base address or the name of array. Name of array is referring to the base address. So, we can access these variable with the help of pointer also, as we were doing with the help of array. So, both are giving the same results. Now, we can also create a array of pointers. Array of pointers means every variable, every element in that array is itself a pointer. So, every element in the array is itself a pointer and it is pointing to some different memory locations. So, it is pointing to a memory location A, this is pointing to a memory location P, and this is pointing to a memory location X. So, everybody is different. Like here we can declare like character pointer name 70. So, it will store 70 names, but the character pointer, they will be stored in an array and 70 pointers will be stored in a character array, and each pointer may point to some name. Float asterisk marks. So, it will store pointers to undefined float values, because currently we are not having the size. So, it will give error. It is perfectly alright. Double pointer. So, it stores the pointer to undefined float values, and we need to give a size, we need to provide a size and the values to these pointers. We can use pointers and 2D arrays. Using pointer, we are pointing to this, but if we use like this, then this is fixed. These size are fixed of 20. Another thing is constant pointer. The pointer variable can also be constant, or I already told you that constant variable cannot change its value during the program execution. So, similarly, constant pointer cannot have different address once assigned. So, integer pointer constant pa equal to address of a. Now, this pa cannot have another address, or this pa is not cannot be, we cannot use pa plus plus kind of things, because pa plus plus will need to change the address, which is not allowed in this situation because it is a constant pointer. So, it will not be allowed to change. So, like here, but what happens int b, and we are having a constant integer pointer pb is equal to address of b. So, if we are referring to a value, and that may also be a, if we have like constant int b, then it cannot be changed, but with the help of pointer it can be changed. We can get to that memory location and we can change. Like for example, we can have a constant int b equal to 5, and we are having one integer pointer p equal to address of b. And what will happen now? If I write pointer p is equal to 10, the value at address p will be converted to 10. So, that will breach this entity of constant value. So, while programming we need to keep this in mind. There is another type of pointer which is called void pointer or generic pointer. Generic pointer basically are the pointers which can made to point any data type. That means now we are not fixing it to particular data type, rather we are declaring it as a void pointer. That means we can on the time or as per the requirement we can convert it to any type. So, it is simply having some address. Addresses are similar, there is no relation with the type. So, any address can be stored by them, but if we want to access the value, then we will convert this into particular. Because why it is being done? Because whenever we are referring to some value, we require how many bytes to be read. Like here we have converted it into integer pointer. That means now we are accessing 4 bytes after that address. If we are converting it into character, then only 1 byte will be used. So, that is why where you want to access that pointer, you need to convert it into particular type. So, you need to typecast. Typecast is not needed during the address, and when we want to dereference, then the size of the data location is required. That is why we need to dereference it and we need to perform a typecasting. So, that is all for today's lecture, and in the next lecture we will do some more good topics like searching, sorting and other things which we can perform in C language. Thank you. I hope you enjoyed the lecture. Thank you very much.